Hello, my name is Carter Campbell. I'm a member of the first LEGO League team, the Sparklers, Team 24442. Today, I'm going to be telling you about the decision-making matrix, something you can use to make decisions about something. So, one of the things that we used this semester for our team was figuring out what missions we wanted to do. So, we had a grid like this, and we set difficulty levels such as high, medium, and low point values. And then over here, we had how difficult the mission was to complete. So here we have easy, medium, and hard. So using this, you can figure out what missions have the highest point value and are the easiest to do. For instance, mission number 3, which is animal conservation, has a very high point value, and it's reasonably easy to complete. So that would go in this box. Now in this box, which is the center box, which is medium point value and medium difficulty, you could say that the service dog, mission number 2, is fairly easy, but with some difficulties, and has a medium point value. Also, with mission 6, milking automation, that is reasonably easy to accomplish and has a reasonably high point value as well. Now, this could also be applied to robot. For instance, if you wanted to figure out what kind of a motor system that you attach attachments to, you could use a grid such as this one, where you have 3 different types of motors systems and figure out criteria that you want to have for the motor systems, and you assign point values to them. So motor types could be just a bare motor, a 4-bar linkage, or a power takeoff. And then up here, you would assign various criteria, such as efficiency in missions, or how quickly you could change attachments. And then we would assign point values to this to figure out how important these criteria are to us in our robot. So efficiency in missions, we want these missions to run reasonably efficiently. So I would put that at about a 4. Then attachment changing is also very important because we want to spend the least amount of time in base. So that would probably be about a 5. And then the bare motor, we figure out how well each of these candidates meets these criteria and assign point values to those. So for the bare motor, the efficiency missions could be pretty efficient, but it's generally not incredibly efficient, so I'll probably assign, say, a 3. Now, it's not incredibly easy to attach and take off attachments off of a bare motor, so attachment changing, I would say, is about a 2. Now, the 4-bar linkage, the efficiency in missions is pretty high, so I would say that is about a 4. Then it is very easy, generally, to take attachments on and put off and put them on of a 4-bar linkage, so attachment changing would probably also be about a 4. Now, power takeoff, efficiency in missions is generally pretty low if you just have the bare power takeoff, but if you gear it so that you can use it on multiple planes, then that greatly increases your efficiency. So that would probably be about a 4. Then attachment changing, depending on how you set it up, it can be very easy to take things on and put things back on. And so that would probably be about a 5. Then how we would analyze this is we would take our criteria number and multiply it by the number that we set in that criteria for each candidate. So for instance, the baromotor will be 4 times 3, which is 12, plus 5 times 2, which is 10. That equals 22. So the baromotor has a point value of 22. The 4-bar linkage, efficiency emissions, 4 times 4 equals 16, plus 5 times 4, which is 20. And so the 4-bar linkage has a point value of 36. Now the power takeoff, we have efficiency emissions 4 times 4, which is 16, plus attachment changing is 5 times 5, which is 25. And so power takeoff has a point value of 41, which would show that the power takeoff is the best thing to use. Now you can use these kinds of systems in all sorts of different things. You can use them for deciding like team colors, or things like robot, or things you should do for project. You can use them for all sorts of things. Thank you for watching this video.